Hello, guys. Today we're going to go over assignment number 7, which is called carrying capacity. And before we start to take a look at the assignment itself, I thought it'd be very important to take a look at this graph right here, because this is a graph that represents population changes over time. So you can kind of see at day 0, this population over 12 days rises rather fast, rather quickly. So between 0 and 12 days, we like to call this exponential growth. It does look like a parabola that you might see in math, like the equation y equals x squared. And the reason why population size goes up like this is due to there's probably an abundance of resources. There's probably a lack of predators, lack of disease, and other issues that might decline a population. And that's why you see a rapid rise in this population size. Now, eventually, though, you hit a point, which you can see here, where that population size starts to flatten out. For this case, it is 200. We call this line in ecology the letter K, and it represents carrying capacity. Carrying capacity is the maximum number of individuals that ecosystem can support. Whether it's resources, whether it's predation, whether it's disease, every population in the ecosystem has a maximum it can support. This just so happens to have a flat line, but typically speaking, over time, eventually that line might eventually crash. So we're going to examine this idea of carrying capacity with assignment number 7. Uh, you can go ahead and read the information, but you will need the Google Sheet. You will need the Google Slide, because we will be doing a little bit of graphing again. And here's the task itself. So here's our objective for this assignment. It's to categorize factors influencing population growth as density dependent or independent and how they are different. And then we want to analyze and interpret data to explain how these factors affect the flow of energy and matter and how they affect population size. Simply put, what is a maximum population ecosystem can support? The carrying capacity. So nothing to do on slide 1. Maybe just add your name right here. But slide 2 says what factors influence how many individuals an ecosystem can support. This is our main objective for this assignment. Nothing for you to do there, but something for you to think about as you're completing the activity. Slide 3, there is a video. You might want to hit present and just hit play to start the video. I'm not going to play the whole video myself, but once you finish, there's a little area for you to respond to this prompt. What are some factors you believe may eventually limit the population size of humans on Earth? What do you think is going to happen one day where our population, going back to our graph, is doing this? What do you think might take place that eventually causes our population to even out and perhaps even crash? Slide 4 is an experiment where you will be doing some graphing and interpreting that graph. So we have an experiment done where there was drought in New Mexico, and they were determining if rainfall had any impact on the number of fawns surviving. So you will input the data from the table I've provided you into the graph over here. For example, 1995, there was 11 centimeters of rain, 12 fawns survived. Then there was 1996, 3 centimeters of rain, and 0 fawns surviving. And then in 1997, 4 and 0. And then in 1998, 19 and 32. So I'm not going to finish this graph for you. I'm going to let you do it yourself. But you should notice some lines forming where this dark blue line represents rainfall and this light blue line represents fawn surviving. So once that graph is completely filled up to 2002, you do want to go back to your assignment and paste it into here. Resize it, reshape it so it fits. You also want to paste it on slide number 5, which I'm going to do so right here. And this is not a completed graph. Your graph will be all the way through 2002. But you want to answer these questions. How did the plot for rainfall change over time? So explain what's happening to this blue line from 1996 to 2002. Describe the fawn rate over time. So that's where you explain what this light blue line is doing over the 6 year period. Is there a relationship between rainfall and fawn survival? For instance, if rain goes down, what happens to fawn size? When rain goes up, what happens to fawn size? Is there any connection or correlation between the two based on this graph? And then the last question, why do you think rainfall might influence population size? What does rainfall provide this ecosystem? What does rainfall do for the fawns? Next is some reading. We do want to discuss what is density dependent factors and density independent factors. These are things that can control a population size that increase the death rate or reduce the birth rate. Some are density dependent, meaning that these are influenced by population density, meaning that it has a higher impact the more dense the population is, versus density independent factors, where population density does not really matter in terms of its effect on population size. I usually like to think of density dependent as being natural, a little bit more biotic, and it's less important when population density is low. And what they do is they regulate population size by decreasing birth rates or increasing death rates. Density independent, I think, is a little bit more abiotic, where they increase the death rate and tend to be a little bit more like natural disasters and whatnot. So there's a video to watch on these limiting factors. Question one, I want you to define limiting factor. The answer here. Question two, give an example of density independent, an example of density dependent, and then which factor you think will affect humans the most. Slide 8 is some matching. So you want to determine, is this a density dependent factor? If that's the case, you would move it to its location. If you think it's a density independent, move it to its location. And again, think about like a flash flood. Is that biotic or abiotic? If it's abiotic, it's probably density independent. If it's more biotic, it's probably more density dependent. And again, competition, predation, disease, resources is density dependent. Natural disaster type of things are a little bit more density independent. Slide 9, we're defining carrying capacity. You could play this little video right here if you want to have them explain this graph a little bit more. This graph looks a lot like the one that I showed you earlier, where you have this carrying capacity, and there's an overshoot, and the population's kind of going up and down to an extent. Because question 10, the last thing you need to do is look at this graph, read this statement, and put the letter that represents what is happening on this graph. Letter A, B, C, D, E, and F will be located somewhere in these locations right here. Make sure you're not just guessing, that you're actually reading what's happening. Maybe try to put them in order and go from there. So brief overview of carrying capacity, a very important aspect of any ecosystem. And it's, of course, its population size. It is impacted by density dependent, density independent factors, and it's impacting even our population size today. So going back to our essential question one, what is a maximum number of people the Earth can support? Ecologically stated, what is the carrying capacity of human beings on Earth? And think about it. Are we near that carrying capacity today? Will we reach that number in the next 100 years? And if so, how will that impact our lives? Thank you, folks. Have a good rest of your day. Any questions or concerns, please email me, text, or whatever you need to do.